Okay, hi everybody, it's Simon here. We're going to have a little chat about problem solving today. Problem solving's a phrase that's bandied around in maths quite a lot, and we talk about problem solving questions. But I'm not sure whether everybody knows quite what we mean by it. So I just want to have a little think about that. And then in the next videos, we're going to do a few examples and maybe apply some of the strategies we're going to talk about to some real life questions and see how you might start going about some of these more difficult questions. Okay, so first of all, let's have a look at a couple of questions. So if I was to give you a question like that, I think most people would know how to go about it. You would have a method. Hopefully you'd be using the lattice method and you'd be multiplying them together. It would obviously appear on a non-calculator paper. Nice and clear, very, very obvious what it is we need to do. If I got a question like that, so let's just take a minute to read it. Local football club have just reached the county cup final. They want to bring 29 coaches to the final. Each coach has 52 seats. How many supporters are going to the final? So actually, there's a little bit more work there, isn't there? So we know there's 29 coaches. On every single coach, there's 52 people. So actually what we need to do is to multiply 29 by 52. So this question here is actually the same as this question here. The only difference was that the one on the right, this one, the one with the words, does not tell us explicitly what it is we need to do. We have to decide what maths we're going to do. So I would say that is a problem-solving question. That is a problem-solving question. So it's something we need to think about it. We need to read something. We need to understand what it's about. We need to decide what maths we're going to do before we do it. So that's the problem. And actually doing the maths is probably the easy bit. So let's have a look at another one. So this is an exam question. It was a 2-marker in an exam. So we're given a little bit of information. We're given a drawing. There's some x's on there. That length there is x plus 1. That length there is 6. That's 4. That's x minus 1. It says all the measurements on the diagram are in centimetres. Find the value of x. Okay, so it's not clear how to go about that. I think what you would need to do, first of all, is to maybe have a little think about it and decide what maths it is you need to apply. So the strategies you will be putting in place is before you begin it, is coming up with a plan. So that is a problem-solving question. It is not super clear what to do. You have a problem to solve. It is not just doing maths. Let's look at another example. Okay, so this one, I'll just move me out of the way. This one is 5 marks. So I think that tells us something, doesn't it? It tells us that there's quite a bit of work here. And I don't need to tell you what 5 marks could mean in an exam. It's a big, important question. And there's clearly a lot to do on it. So we're told we've got a rectangular frame made from 5 pieces of metal. These pieces of metal are straight, and we're given we're given a length there, we're given a length there. We're not told that one, we're not told that one, and we're not told that one. And we're told that the weight of the metal is 1.5 kilograms per meter. So for every meter, it's 1.5 kilograms. And we need to work out the total weight of the metal in the frame. So that's going to need a little bit of thought, and we'll come back to it in a second, and we'll have a look at it and maybe have a go at that question and work through it in a nice structured way. That type of question there would be answered very, very badly in an exam, because I think people would maybe panic a little bit, not think about it logically and go through it in a structured way. So that's what we're going to talk about in this video, of how how we can go about these types of questions. I'm not going to actually do it in this video. I'm going to do that in the next video. So let's have a think first of all. So we've looked at some what we call problem solving. So let's have a little think about what we really mean by problem solving. So what kind of question makes a problem solving question? So first of all, it might be that the question is pitched in a context. Yeah, so it might be something like the previous one we were talking about, where it's talking about lengths of wire. And so lengths of wire are real things, so it's putting it in real life context. There can often be a lot of words, and I hear people talking about wordy questions, and I don't like wordy questions. But the key with wordy questions is we're going to have to read them and we're going to have to understand them. And before we're doing any maths, we need to do them. So often problem solving questions have a lot of words. It's not always obvious what maths you need to do. So it won't say, like on that multiplication question that we looked at a second ago, with the buses and the people, it didn't say you had to multiply the two numbers together. That's what you needed to decide. So that developing this plan, and I'll keep using this word plan, about your problem solving process is really important. Okay. Often a problem solving question, it can often just be the fact that it's more than one step. So it's not just one bit of maths that needs to be done, it's two bits of maths. So maybe there's an element of kind of, first of all, when we're coming up with our plan before we start, is that we're working backwards to decide what it is we need to be doing. So first of all, I need to be finding the length of that piece of wire. Then I need to find the weight of it. How do I find the length? So there's a step-by-step process going on. So we'll come back to the questions in a second. You'll see what I mean on that. Okay, so those, I would say, are what problem-solving questions look like on an exam. You know, you might have other ways of describing them, but that's often it. Real life context, lots of words, not absolutely telling you what maths you need to do, and often multi-step questions. That's what we're talking about. Okay, so let's have a think about strategies. So the way, when we spot one of these questions, or we see one of these questions, I'm not quite sure how to go about it. What strategies should we be using? What should we be doing? So let's have a think about that. So first thing I would suggest is have a look at how many marks it is. So that one with the wire we looked at, it was 5 marks. That tells you something. That tells you this is a lot of work. This is not a simple task that is just going to be one thing to work out. It's going to be multiple steps. I'm not going to give you 5 marks for doing one thing. If a question said 1 or 2 marks, that tells you something too. It's a simple job. You know, if you can decide what to do, it's going to be easy. Okay, so that's the first thing to look at. That sounds obvious. Read the question. But often people don't. And when I say read the question, read everything. There might be something somewhere that is going to give you a real clue on this question. So read it very, very carefully. As you're reading it, highlight key information. You don't get marks for doing the highlighting, but it can help you get those marks. If you don't have a highlighter, you can just underline it. So which bits of the question are important to you? Which bits are you going to be using to develop your plan? And then your plan is going to lead on to the maths. So that's really, really important. Okay, so things you might want to do to help you. Draw a picture. Yeah, a little picture might help. It might be that it's a purely worded question. There isn't a drawing there. And actually a little sketch might help you. and you can get marks for the sketch. You know, if you draw a little sketch and you draw some dimensions on it, you write a length on it, that might be enough to get you a mark on a GCSE question. Maybe this is an algebra question. Maybe really what you need is to apply algebra to solve this question. So could you look at what we've got, look at what we're given, and could we make an equation? Okay, could that equation help? You know, then once you've got the equation, maybe it's just a matter of solving it. But is there an equation we could create from the information? And often when you see X's and Y's on the sketches, like the one we saw earlier on with that rectangle, that looks to me like it's got something to do with an equation. There's an equation you could create. It seems to be an algebra type question. It seems to, you know, that would be my hunch on that question. So could you do that? Could you create a ratio table? You know, it might be a question to do with proportions or something like that. Go and have a look at the videos that we've created for ratio tables. Ratio tables are very, very powerful tool when you're dealing with proportion and ratio. So is there some way you could build up a ratio table from what you've got? I've talked about the plan a lot, haven't I? So the deciding what it is you need to do first is often the hardest bit. And often if you can decide what to do first, then you're a long way to the answer. So that plan of deciding what to do is key. And often working backwards from the end can help you get there. So think about what your end game is here. What are you actually trying to find out? Be clear what it is you're trying to find out. And then maybe think, oh, well, to get that, I actually need to find that first. Yeah, so you can work backwards from the end of the solution. And as I say, we'll look at some examples which might make this a little bit more clear. Okay, and the last one is, and this is often a good idea to do at the start of a problem solving question. So when you've looked at the question, you can see what it is you're aiming to get. Can you make an estimate as to what it is? You know, what sort of number are you looking for if it's a number? So on that rectangle where we're looking to find X, what kind of value of X are we looking for? And that might help you check your answer at the end. So when you get to the end and you know you're looking for an answer that's maybe 5 centimeters or 6 centimeters, something like that, and you get to something like 472 centimeters, you can know that something's gone wrong somewhere. It'll just give you a little bit of a trigger to go back and let's double check. Did I get my units right? Did I set my equation up right? Did I solve my equation right? Whatever steps you've taken to the end, you can go back and check in it. So those, I would say, are the things you can be thinking about. How many marks, reading the question, highlighting things, all helping you come up with a plan. And then we start working through it. So how can we get there? Draw a picture, make an equation, organize it in a ratio table, working backwards from the end, making estimates, all part of the problem solving strategies that are going to help you be really successful in this area. Right, okay, so the next videos are going to be going through specific examples, and we'll be thinking about these strategies as we're doing it. So the way to approach real questions. Okay, so I hope that was a useful introduction. Okay, see you later.